In the last segment, we focused on developing IUPAC names for haloalkanes, also known as alkyl halides. In this segment, what we're going to focus on is how we determine the so-called common names of haloalkanes. In addition to the IUPAC names that you learned about, where you find the longest carbon chain, name all the branches that come off of it, etc., you will also very often see haloalkanes referred to by their so-called common names. In order to develop a common name of a haloalkane, what we're going to do is we are going to look at, back if you go to the Quick Start Guide to Alkane Nomenclature from Chapter 3, and you will find this handout about Quick Start Guide to Alkane Nomenclature back in the Chapter 3 materials. We talked back there about how we could refer to branches coming off of the parent chain by these different names, such as isopropyl, isobutyl, sec-butyl, etc. In order to develop the common name of a haloalkane, what we're going to do is use these different branch names to incorporate into the name of the haloalkane molecule. So the template for developing a common name for an alkyl halide is that you're going to name the alkyl group, such as tert-butyl, and then you're going to put the halogen name after it. Hence the term alkyl halide is the generic name for this. So specific examples would include, if we were to say, provide the structure for the molecule referred to as neopentyl chloride. Based on the common name neopentyl chloride, what this is going to refer to is that you have a neopentyl group, and hopefully you recognize what a neopentyl group looks like based on the information there. So I'm drawing in my neopentyl group, and then where the squiggly line is within the template, that's normally where the branch comes off of the parent chain. That squiggly line here in the common name is going to represent where the halogen atom is found. So in the case of neopentyl chloride, we'd be putting a chlorine atom right there. So the squiggly line in our various branch names now represents in the common name where the halogen atom is located. So neopentyl chloride would be the structure shown here. Let's do another example here of coming up with common so-called alkyl halide names for molecules. And in this example, what we're going to be asked to do is provide the structure as a line angle formula or condensed structural formula, whatever you like. We're going to draw the structure of, let's do sec-butyl iodide. So sec-butyl iodide, the main thing we have to keep in mind in order to get this right is you have to remember what a sec-butyl group is and attach the iodine atom to that. So we're going to bring in our iodine atom, and then our sec-butyl group was that 4-carbon total group that has the branch there to a methyl group coming off at carbon number 1 of our group. And so that's going to be our sec-butyl iodide. So what we did there was we just took and we looked at our structure for a sec-butyl group that was right here. And then where that green squiggly line is was where we affixed our iodine atom. So that's going to be our sec-butyl iodide. There are a couple of names that you need to be familiar with in addition to what's listed on this nonlinear branch list. And those names that you need to be familiar with so that you can come up with common names for alkyl halides are, you need to be aware of these additional ones. So the additional common names for these groups are going to be vinyl, refers to an alkene group of 2 carbons that is directly bonded to a halogen. So X here is our halogen atom. And the group that I'm going to highlight in pink here is referred to as the vinyl group. So vinyl group is a 2-carbon chain that is an alkene group. So the particular name of this molecule, where we just have X for a generic halogen, would be a vinyl halide. A specific example of this, which I'm going to show in blue here, is if we took that same group, our vinyl group, plugged in a chlorine atom, we would refer to this as vinyl chloride. So just like you've committed those alkyl group names such as tert, butyl, isopropyl, etc. to memory, you do need to definitely commit the term vinyl to memory here so that you'll be able to identify things that are referred to as vinyl halides. The last name that you need to be familiar with when we're talking about these common names of alkyl halides is this situation where, again, X is going to represent your halogen, and here the chain that I have drawn, which has 3 carbons in total, 1, 2, 3, is referred to as allyl halide. So the allyl group refers to this 3-carbon group with the alkene there at carbons 1 and 2. And the halide, of course, refers to that X atom, which is a halogen. So an allyl group is always going to be that 3-carbon group that has a double bond connecting carbons 1 and 2. The reason we call that an allyl group is if you think back to when we were talking about free radical halogenation at the allylic position, that carbon atom right there is referred to as the allylic carbon. Remember that that's the carbon when we were talking about free radical halogenation. When you form a radical at that location, there can be resonance stabilization there, and that's why that position has a special name that goes along with it. So when we say allyl halide, what we're referring to is that there is a halogen atom bonded at the allylic position. So let's go ahead and do an example problem to illustrate that we understand what we're doing there with allyl halides. So here we have our, what hopefully you recognize as the allyl group. So our 3-carbon group there, carbon-carbon double bond connecting carbons 1 and 2. And then we have an iodine atom bonded to that. So our full name here is going to be allyl iodide. So with that, hopefully you have a good understanding now of how to come up with the common names of haloalkanes. The number of molecules that we can name using common names is relatively limited because it's going to be constrained by the terms that we use for typically different branch names, different alkyl groups. So vinyl, allyl, and then the terms that you already learned up here at the top of the page with isopropyl, isobutyl, sec-butyl, tert-butyl, etc. So this would be a great opportunity if you have got a little rusty on these alkyl group names to refresh yourself on that, because you are going to need those alkyl group names in order to come up with the common names for these different molecules.